We're starting the chemistry unit 2, paper 1 for May, June 2018. Alright, so let us begin. Hopefully we have some repeats here. The paper is a bit glitchy. Don't like that at all. Alright, so in which of the following pairs of formulae is the molecular formula and the empirical formula correct for butanoic acid? So bute is already 4, right? And butanoic acid, what would be its? What would be the best answer? I hope everybody can see it now.
C.
Repeat?
C as in cat.
What says in cat? Alright, so butanoic acid. Alright, so it would have 2 oxygens, therefore D is foolishness. It should have 8 hydrogens, therefore B is foolishness. I think this is the empirical formula that states it apart. Hold on. You sure that C would be the best answer?
Why is it C though?
Wait, hold on. For A and for C, right? Are the molecular formulas in A and C correct?
Yeah.
So what is the? How do we get the empirical formula from that then? Which empirical formula is correct?
I'm thinking A. Don't you multiply like each of them first? They move from empirical to molecular.
What number is? Alright.
Wait, but
Oh.
from O2 to O, that means you would have to divide by 2.
Mm-hmm.
8 divided by 2 would be 4, but it says H2, not H4.
That's it.
Alright. So what I don't know. I always think about factorization when it comes to this, right? The lowest value that can be going to all of them would be 2. So if you factor out the 2, then it should make sense. Because 2 2s will give you about 4 carbon, 2 4s will give you about 8 hydrogen, and 2 1s will give you about 2 oxygen if you look at it. I don't know. I always I always think about factorization when I talk about it, but like I don't know, right? But C would be something like the better answer, right? We're looking at the lowest whole number ratios, right? Because if you do it as empirical formula in A, you should get equal numbers of carbon and oxygen, which is not true, right? So you have to know the magnitudes by which we increase them, right? So carbon is always 2 orders of magnitude above oxygen within its molecule. Number 2, which are the following compounds show optical activity? What gives optical activity again? Remember, would it be our constitutional isomers, our diastomers, or our enantiomers?
The enantiomers.
Wonderful.
The one with symmetric carbon.
Yes. Repeat the type of carbon you said.
Asymmetric carbon atom, so it has 4 different groups attached to it.
All right, wonderful. Chiral carbon. All right, so we have that. So what would be the answer now?
B, as in boy.
Okay, so 1 and 3, wonderful. All right, which of the following isomers have identical boiling points?
I would say C, because I remember reading that optical isomers have similar physical and chemical properties.
Right. So based on it, right, to be very honest, they're literally the same molecule, right? If you look at it, they have the same structural arrangement, right? So they're not constitutional isomers generally. So they should have the same structure. The only thing about it is that they're optically active for some, right? In some way, right? You're gonna have your R. Let me see if this is an R isomer. Hold on, that would be 1, 2. So you have R and then you have your D isomers, right? So the only thing about it is its reaction or its activity with polarized light and the fact that it's non-superimposable, right? So everything else should remain the same or identical, right? So I have that there. Number It's so foggy. Give it a second. Alkane molecules are cracked into smaller molecules, which may include smaller alkanes, alkenes, and hydrogen molecules. Which of the following equations show the cracking of dodecane? So you need to make sure that the constituents add up to give you dodecane. Is A the answer?
Yes, sir.
Alright. Which of the following statements about polyunsaturated oils? Alright, so we saw this already. I'm not doing over anything that we do already. An alcohol is treated with, we did this already. Alright, finally time for repeats to start coming in. Oh wow. We have our propene here, right? Notice that it doesn't make any sense to say one propene because with propene specifically, you're gonna always have one, right? It's treated with hot acidified potassium permanganate, right? Which of the following products is or are formed? If you react a small alkene, right, with a hot acidified potassium permanganate, you should reduce it to a point where it becomes carbon dioxide and water. Now we have to argue whether or not there will be 2 carbons left or 3 carbons left. Noted that it's a 3 carbon molecule. If it reduces 1 carbon, you will have 2 carbons left. Therefore, it would be ethanoic acid, wouldn't it? And carbon dioxide and water. Agreed?
Yeah.
Alright. Which of the following methods could not be used to differentiate ethanol from propanol? No man, we're taking too
Using
long. Challenge reagent.
using challenge.
Wonderful. Thank you so much. Which of the following statements is true for the nitration of benzene?
With it not
Wait, repeat?
talking about, yeah. I mean, it-
I'm not
why not D?
hearing what you're saying properly.
Why not D at the or A?
Oh, for 8. Okay. What is the empirical formula of hold on? The empirical formula of ethanol. What is the molecular formula of ethanol? Somebody tell me right now, please. In 5 seconds. 5, 4, 3, 2, 1. Nobody? Alright. So ethanol, we know it's an aldehyde, so therefore this is the structure of ethanol, alright? Really simple structure. That means that the molecular formula would be what? C2H4. C2H4O. Alright? Propanol now would just be C3H5O. Na so. Because you just have a carbon here. So it'd be 1, 2, 3, 4, 5, 6. So it would be 6 actually. Sorry about that, right? So it would be that. So the empirical formula would be what? For that of for this one it would be what? CH2O. For this one, I think it would be CH6O. But technically, aren't these some other like no, it's
Two.
H3 to be a problem, right? But I think it would be. I think they would remain. To be very honest, I think they may or may not remain. But I don't think you can tell the difference. Yeah, well, I think you can tell the difference between their empirical formulae. I think you can, because they won't be the same. Which of the following statements is true for the nitration of benzene?
C.
Nitrobenzene a pale yellow liquid. Is nitrobenzene a liquid or a solid? Is it a precipitate? That's the only thing that really allows C. Well, really, I'm debating C on, right? Whether or not nitrobenzene is soluble or insoluble. Is it soluble?
Let me check.
All right. Well, I mean, it's not if it's soluble, it's asking if it's a liquid overall. So I guess so.
It's a liquid.
It's a liquid. All right. So nitrobenzene is a liquid. Wonderful. Right. So the main product formed from the reaction above, we have this carboxylic acid. All right. And then we have this here. This would be a ketone. So it would be the reaction here.
B.
I think B would be the best answer.
Sir, could you explain?
Wait, hold on. Let me check something before I put B as the best answer here. Hold on.
What is it?
A.
Wait, what's happening here? Alright, hold on. So within solution, this is it's ethanol chloride. Then why you never put ethanol chloride there? You just put C1. Alright, ethanol chloride. Therefore it should be a chlor. Oh, go ahead.
The C1 is chlorine.
I think it should be because what is that? Alright, so
Oh,
if you if you know it's ETH, right? F, right? And then we know that it should be ethanoyl, right? And in order for it to be F, this has to be stabilized. That means that the other must be a chlorine molecule. Because we know one of the things from module 1, we should be able to draw any and everything from the name of the compound. Right, so we have that there. So I think the C1, I think it may be a typo, probably. Right, it should be Cl. It should be a chlorine. So the chlorine should attack where? The OH or the carboxylic acid group?
the OH.
Oh, okay, the OH. Because we know that ethanol chloride is an acidic group. That means it must attack the basic substituent, which is the OH. Right, and that's why I believe it will attack there more so than the acidic area. Because once, if you look at it again, right, let me try to explain it a little bit more. When this dissociates, it's going to give us this, right? So we're gonna have that there. When the ethanol chloride dissociate, well, it's gonna react, right? Remember, it's going to have its chlorine, right, bonded to the carbon, and you have your group of there, so right. These are two negative and electronegative compounds, right? No, it's giving no. Why? That's what it's giving, right? So it may be possible to occur in some way, shape, or form, but it will not be the most apparent product. I think B would be the safer one, to be very honest, right? I understand that the hydrogen would actually break off and create this, and then this will bond here, right? But most likely, I think the OH group would be what it attacks more so than the carbonyl group, right? If you look at it again, it could be due to steric hindrance, because if it combines here, we're going to have two carbonyl group here, so I don't think this should be able to work, right? So it's probably because of the stereochemistry, right? B would be more preferred. For the following properties, which of the following properties are the compounds ranked in the correct order? So we're looking at all of this. What does pKa say about acid strength? Hello? I'm working off of you guys, So when the vibes drop, right, the paper them stop work. Just saying. So what's happening? What does pKa say about our acid strength? So we have acidity. What is the relationship between acidity and pKa?
The smaller the pKa value, the stronger the acid.
Inversely proportional. Wonderful. Right? That means that the smallest value gives the strongest acid. So ethanoic acid is in first place coming in, right? Followed by the phenol, followed by ethanol, right? And we know what acid strength speaks about. That means that let's look at this now for stability. Do we say that the phenoxide, okay, the phenoxide ion is here is less stable than, well, the ethoxide is less stable than phenoxide, which is less stable than ethanoate, which is true. Dissociation, ethanol doesn't dissociate greatly, its equilibrium lies to the left, so that is untrue. And then the ease of protonation would be gifted to the stronger acids as we go down. So it should be ethanoic acid, then phenol, then ethanol. So 1 and 3. Anybody have any issues with that?
No, I agree.
Alright. Everybody else fine? I don't answer that question because it repeated, it's fine. The functional groups present on an amino acid are the amine group and the carboxyl group. These are what amino acids exist as. What does it exist as?
These with the ion.
As with ion, wonderful. The product formed by the polymerization of propene may be used as a
Plastic material.
Alright. 15. Which of the following compounds are have the repeated unit shown? This repeated as well. So nylon and polyamide, and it is not amino acid because amino acid is not a polymer, therefore it cannot have a repeated unit. 16. Which of the following statements is not true of the detection? We saw this as well. E equals to the standard deviation. Which of the following instruments is not used in stoichiometry?
A.
What is a barometer used for?
Atmospheric pressure.
What is a mammometer used for? MAM. Just asking. Mammometer? You said pressure?
They both measure pressure?
Yeah.
Oh, okay.
Right. And everybody knows what a wind vane. I've never seen a wind vane since the 5th grade. Right? Wind vane is, wind direction. Alright, so 18. Sodium sulfite reacts with potassium permanganate according to the following reaction. Alright, so we have that there. A titration of 25 centimeter cubes of 0.04 moles sodium sulfite solution required 20 cm cube of acidified potassium permanganate for complete oxidation. The concentration of potassium permanganate is. So looking at this now, titration of that. Alright, so sodium sulfite required 20 centimeter cubes of that. So we're looking at what? What do we want to focus on? Right? We have to look at the concentration of potassium permanganate per se. So we only have the concentration of sodium sulfite. And those would be the sulfate ions we're focusing on, right? So let's see this. Would it be a 5-to-2? Well, I don't think that makes sense. But what do you think the ratio is? Is it a 5? Is it a 1 to 2.5 ratio between the manganate and the sulfite? I mean, come on, people, talk.
A one.
Repeat.
You said 1 to what?
As with a 1 to 2.5.
Oh yeah.
Alright, so it's a 1 to 2.5 ratio because we have 2 and 5, so we divide both by 2. Alright, so 5 divided by 2 should be 2.5, I believe. I hope I am not that mathematically disillusioned, because that would be bad news for my calculus grade. So what's happening here? How do we get the concentration of potassium permanganate? Because we know that the sodium sulfide would be 0.04, right? And that means that that is 2.5. So if in the event, right, that, yeah, so what is that? So if 2.5 moles gives us 0.04, or is 0.04, right, how many moles is 1? Well, what is the mass we get? We don't know the mass. Can we use a mole statement to get this? Can we get a mole statement to get this? If that is
Wait, what are you trying to
0.04,
do?
repeat?
What
Wait,
I did was use the equation N is equal to CV.
yeah, we could use that. Hold on. I think this is messing up everything.
Multiply, find the moles of the sulfite, sodium sulfite,
All right.
and then, here.
Hold on. Why is this thing slowing down? Alright. So we can use. So you guys are saying fundamentally the same thing, right? The number of moles is equal to the concentration times the volume, right?
Yeah.
Moles What did you get as the answer?
Let me get my calculator.
I got 1 times 10 to the negative.
And what would that
Same.
be outside of
That'll
index
be
form?
moles. What?
What would that be outside of index form?
I didn't hear what you said.
Standard form.
Oh, standard form. It'd be 0.00. Are you rating it?
Wait, okay, 0.001.
1.
That same thing that you get kilo?
Mole.
Yeah.
So what do you think would be the closest value?
You're not done there yet.
Okay.
Just calculated for the sulfite.
Okay, so we
So
have
we
that
had used
mole for the sulfide. And then we have to use the mole ratio now, right?
Yeah.
So it's 2.5 to 1. So what do we do to get that ratio? What are we going to divide by or multiply by or subtract? What are we going to do?
So divide by the 2.5, but the 0.001.
Is that right, everybody?
Yeah, she's right.
All right, 2.5.
Yeah.
What's the answer?
Four times 10 to the minus third, something like that.
4 times 10 to the minus third.
Minus 4.
Or to the minus 4 power. Alright. So what would be the answer for... Okay, so what are we continuing to do?
Sir,
Go ahead.
wouldn't we change the centimeters cube on the volume to dm cube to match with the concentration?
Wait, yeah, you would. You should have dm cube. So what's happening?
And then as yet, that there that you got is just the amount of moles for the gotta now divide it by 0.02 pm cube.
Wait,
The value
repeat
that
what
you
you
just
said.
got. That value that you got there is the mole, the amount of moles of PMNO. They got divided now by the volume to get the concentration, which will be 0.02 is the
So divide by
concentration,
the
I believe.
volume. 0.02 is the volume.
0.02 mole per dm cube.
All right. So we're gonna have what?
Yeah.
4 times 10 to the negative fourth power divided by 0.0 what? 2. All right. So convert it. And what would be the answer?
B as in boy, 0.02.
Okay.
Yeah, I got that.
So hopefully can move a little faster. Alright, so let me see what's happening here. Alright. A 300 milligram solid sample containing a silver chloride is dissolved in water. The chloride is then precipitated as silver chloride by the addition of silver nitrate to the solution of the sample. The precipitate is collected, washed, dried, and weighed, and found to have a mass of 525 milligrams. Right? I walked some of you guys through this, so could you guys remind us of what we do here? Or what do you guys do here? The answer should be C, but what do we do here? We don't want to go over time, no, go ahead.
I have to get the amount of moles of chloride. It's a 1-to-1 ratio, so all you just do is the 5 to 5 milligrams. You're gonna divide that by the relative molecular mass of chloride.
Of silver chloride, which is 140 what? What, 43 point something?
143.5.
143 point what?
5.
5, alright. And then that would give us what?
143.5.
5, 0.6, and then you times that by mass of chlorine.
Wait, hold on. So you guys said they get 3.65. So 3.65, right? And then the 3.65, it times it by the what? What do you guys do with it?
You multiply with the 35.5.
Alright, so 35.5, and what is the answer?
129.87.
129.87. The answer is, which of the following alkanes has a wavelength of maximum absorption? What alkenes have a wavelength of maximum absorption? What would it be?
Benzene dog.
Why?
For me, it's because it has more double bond. I was thinking because it's more conjugated than the others. I'm not sure why.
Well, alright. So you're saying that it's aromatic in some way. It has more pi bonding electrons. Interesting. Everybody else? You guys agree? Yes, no, maybe, kinda, probably. No. I'm not sure if you guys are
I
not.
agree. I agree.
Okay, okay, alright. I'm not sure if you guys are like not allowed to speak in your respective households after a certain time, but it's always like after 9 thereabouts, participation just crashes. Which are the following sets of regions? Alright, so we looked at this, right? So it should be what? B. Which of the following species is not a significant fragment of the mass spectrum of ethanol? The molecular ion, right? I don't think that molecular ion specifically. Is the molecular ion significant? Don't think so. Wait, is it significant? I wanna know. Which one of these is significant? And which is not significant? Let's answer the question. The question.
I'm thinking because it's the way I interpret it, that fragment of like that. But
Mhm.
the rest is fragment. I'm not sure.
So what's your answer though? Even though you're not sure.
Well, I put D as in dog.
Okay. What does everybody else say? Let me
I
check
would.
the chat. Oh, go ahead, Kayla.
Oh, I was saying I would put D as in dog.
So I would put that as well, right? I think I put that on the last paper on what 2020 paper. I think it repeated there. Right, so it should be not really that significant of a fragment per se because that's just like one electrons missing from the entire fragment of ethanol or what the entire thing of ethanol. So, and remember what we use to define the entire structure is all the fragments and then we put it together generally. So we're gonna get the molecular ion per se, but we're not gonna know the structure technically until we have all other fragments really figured out. I just answered this because we know that for the 4 grams ethanol or it can be ethanol or carbon dioxide, but with this wavelength it would be with these weight numbers, absorbances, then it would be A. The mass spectrometer was used to determine the relative molecular mass of a sample. Which of the following sequences is the correct order of processes that the sample will undergo in the mass spectrometer? First, we need to ionize, so everything up here says garbage. We ionize, accelerate, deflect, detect. Right? 25. Well, 25. Which of the following molecules absorbs infrared radiation? Which one would it be? It would be ammonia, wouldn't it?
B as in boy.
Yeah, B as in dog.
All right. Right. The mixture containing heptane 2,2-dimethylbutane, hexanoic acid, and heptanol were separated by gas liquid chromatography. Oh, for mine. The stationary phase used was polar. Which of the following? Well, sorry. In what order would the components leave the column?
C.
Well, what is the defining
The
factor here? The stationary phase was polar.
Yeah, the less polar substances will leave at first, then others.
All right. Wonderful. Right. Is this a repeat? Yes, it is.
Yeah.
All right. This is not a repeat chromatography, though. John performed an experiment to separate and identify the components of a compound M with thin layer chromatography. The chromatogram below shows the results of the experiment. From the results, it can be concluded that compound M consists of components
1, 4, and 5.
1, 4, and 5. Wonderful. Right, so 1, right, we have what, well, so that's 5, right? This is 1, and this is, so let's look down, right? A mixture of sulfuric, nitric acid and water shows. Is this positive or negative deviation of Raoult's law?
Negative.
Wonderful. We're on a roll.
Oh, the negative.
Isn't negative curving up and positive curving down?
I think for the boiling point, it's the opposite. For the vapor pressure, the positive would be up, the boiling would be down.
Mm-hmm. Right, so that's how it works. For vapor pressure, it would be.
So,
Go ahead.
can you explain it a bit? Why?
Raoult's law.
When you
Go ahead.
negative or positive,
A negative deviation in Raoult's law, right, should allow the substances to have a lower vapor pressure with a higher boiling point. I think that's how it works. And positive is the flip of that, right? Take a look at your textbooks or your study guides.
wait, repeat that one more time, please.
I think that the negative deviation from what I can remember at this moment would have a increase or a higher than expected boiling point, right, and a lower than expected vapor pressure, I believe. Right, I might probably going to have to look at it again. No.
Okay, so according to the study guide, for the negative deviation, the boiling point is high.
Mm-hmm. So negative deviation, right? The boiling point is gonna be higher, and the positive deviation, the boiling point is gonna be lower, right?
Yeah, and it also says
Go
vapor
ahead.
pressure of the mixtures. And it also says that the vapor pressure of the mixture is lower than expected for an ideal mixture for negative deviation, while it is higher than expected for positive deviation.
Yeah, I remember drawing this in class. Well, doing this thing that I just put in a box in class, right?
I
Because
was
that's
asking, right?
for. Go ahead.
When they say negative deviation, it means that the interaction between the components are stronger. When they say negative,
It should be, because that would allow the
okay.
boiling point to be higher. If the interactions is higher, then that would be more bonding, leading for the boiling point to be higher,
Yeah,
and the vapor pressure to be
yeah.
low. Because we know that once the boiling point
Alright.
is higher, vapor pressure would be low because they're inversely proportional. Right? 30. Which of the following statements about partition coefficient may be true? It is affected with temperature, so I don't think that makes sense. So it has to be in the same. I think the solute has to be in the same state. Two solutions have to be constant. They don't have to be concentrated. So I think it is 3 only. Right. So I hope that you guys understand that. Right. For this now, 31, the extraction of aluminum. Yeah. The extraction of aluminum is an Go ahead.
Partition coefficient does not. Oh, it does vary with the temperature, right?
Yeah.
Okay.
It should vary. Alright, so the extraction weight. I'm so sorry. Now that you asked that question, let me think about the KD is going to. Okay, it's gonna be aqueous upon Arcane. If you increase in temperature, that increases solubility within the aqueous sphere and increases solubility within. But the increasing solubility doesn't change the ratio of solubility. Increasing. Why am I doubting? Why am I doubting myself? Hold on, let me look at it. We'll just start doubt myself immediately. Alright, so the partition which doesn't vary with temperature. Doesn't it though? Because more is gonna be soluble. Well, soluble in it. I think it does. Alright. Let's have a look at this, right? 31. We're moving a bit slow though. Alright, so 31, the extraction of a loop. Okay, so we know this already. Right, if we looked at 18 now, this question now, what is the answer for that? A sample of crude oil contains mainly that, right? In which crude oil fraction would you expect to find it? Somebody tell me.
I was thinking diesel oil.
Wait, what is the answer? B as in boy?
I was thinking C.
Or
I was thinking C.
Yes, sir. C.
Alright. Chlorofluorocarbons. We looked at this and we're going with what were we going with at the first part? We're going with A. Alright.
That's slightly different.
Yeah, it's slightly different, bro. I just saw where the radical sign is put there. For this one, the essentials. Alright. So if we don't have to really look at everything else, well, not really everything else, but the questions that we did already, I don't think it should be a problem. 36. The combustion of ethanol produces lower carbon monoxide emissions than gasoline. This occurs because when compared to gasoline, ethanol has an oxygen in its molecule, which brings about more complete combustion. Sure?
I was thinking D as in dog.
Alright. Did you guys look at octane numbers of compounds? Cause I think my teacher mentioned it and I went through it. Whether or not something's an octane enhancer. But I don't think it's important that much for it.
No, I've never went through that.
Oh, the octane number, I think it speaks to the degree of, combustibility or something like that. 37. During the electrolysis of brine, the chloroalkali industry, in the chloroalkali industrial process, the following reaction occurs at the anode and cathode. Right? What would be the overall equation for this reaction?
Okay.
Wow. Okay, alright. 38. Thermal pollution, in less water being dissolved in water. In the contact process, sulfur trioxide is dissolved in concentrated sulfuric acid to form oleum. Which of the following reactions is the formation of oleum? Well, for the formation of oleum is balanced.
A.
A. Wonderful. Wait, let me check. Alright, it's what? There's 2 sulfur over here. Alright, 2 sulfur there. So there is 3, 4, 7. Alright, that's fine. 40. The compounds of sulfur, such as sulfites, oh, we saw this already. And this would be the troposphere. Alright. And then we saw this already too. This should be lead. Alright, so look at 43 now. The requirements Y, X, Y, and Z for producing photochemical smog are respectively. So
E. Cat.
Cut.
Alright, so we need to have sunlight, then water, then hydrocarbons to create that. Alright. You guys are fine. Chemistry is good. Which of the following, right, hold on, options represents LMNO?
A.
I agree.
Reduction, alright. Nitrogen, alright. So we have that. Wait, hold on. Bacteria, alright, that's true. N is going to be, that's true as well. And O is going to be nitrogen fix. Well, A, right? So we have that. That's fine. Which of the following outcomes are advantages of using incineration as a form of solid waste disposal?
All of the above.
Alright, so all of the above. Imagine, never mind. I think I made a joke about this, about like, what if we use cremation to generate electricity? But that would be a little bit inhumane for some person. That's the end of the test. Alright, that is the chemistry unit 2 2018 paper 1.